Welcome to another edition of Brain Maths. On today's edition, we want to look at conversion from order basis to base 10. We have spoken about the addition and subtraction, including the multiplication of numbers in different bases. But quickly, we want to look at how to convert numbers from order basis to base 10. Let me quickly clarify something. We have numbers in different bases, but the major base that are common are from base 2, which is also called the binary base. Then we also have numbers in order bases. But assuming we have numbers in base 11, for instance, don't forget that I told you in our previous lessons that all the number in any base given to us would not reach the given base. For example, if you're working in base 2, your expected numbers are 0 and 1. If you're working in base 5, the numbers you are expected to have in your answer for base 5 are 0, 1, 2, 3, and 4. So let's say you are now working in base 11. Base 11. We know we will have numbers up to 10. That is 1, 2, 3, up to 9. So for 10, instead of writing 10, in this case, we are going to include alphabet. So anywhere you see A is representing figure 10. If you're working in base 12, which is called duodecimal base, we have numbers ranging from 0, 1, 2, up to 9, A, which is representing 10, and B, which is representing 11. Also, assuming we are working in base 16, which is regarded as hexadecimal base, we will have numbers from 0, 1, 2, 3, up to 9, which represents up to A, which represents 10, B, 11, C for 12, D for 13, E for 14, F for 15. Don't forget that we cannot write 16. So if you are now asked to convert numbers from order basis to base 10, we do this by expansion of all the numbers given to us with the base number. What am I saying is, if you are having 1, 0, 1, 1 in base 2 to be converted to base 10. So the first thing we are going to do here is to give all these numbers powers like this, and then we expand, multiplying each of this number by 2. After multiplying them by 2, we now give all the numbers the powers on top of all these base numbers. So we have 1 times 2 plus 0 times 2 plus 1 times 2 plus another 1 times 2. So these powers will now come on top of each of the base numbers. Now we add out after multiplication. So we have 1 times 2 raised to power 3 means multiply 2 in 3 different places. So that is 2 times 2, 4 times 2, 8, plus 0 times 2 raised to power 2 is 4, plus 1 times 2 raised to power 1 is 2, plus 1 times 2 raised to power 0 is 1. 2 raised to power 0 is 1. So we have 1 times 8, 8 plus 0, 1 times 2, 2, plus 1 times 1, 1. So 8 plus 2, 10 plus 1, that will give us 11 in base 10. So our answer to this is 11 in base 10. That means if we are given 11 in base 10 and we are trying to convert it back to base 2, this is what we will have. And if you're having these numbers in base 2, it represents 11 in base 10. Let's quickly look at the expansion of these two numbers on the board. The first one says 2, 3, 4, 1 in base 6. So we have 0, 1, 2, 3. And that will give us, we multiply each of these numbers by 6. Don't forget, 2 times 6 plus 3 times 6 plus 4 times 6 plus 1 times 6. So give them their powers. So we have 2 times 6 times 6, 36. 36 times 6, that will give us 6, 18 plus 3, 216. Plus 3 times 6 times 6 will give us 36. Plus 4 times 6 raised to power 1 will give us 6. Plus 1 times 6 raised to power 0 will give us 1. So we have 2 times 216. 2 times 6, 12. 2 times 1, 2 plus 1, 3. 2 times 2, 4. Plus 3 times 36. 3 times 6, 18. Remainder 1. 3 times 3, 9 plus 1, 10. Plus 4 times 6, 24. Plus 1 times 1, 1. So you try to add all these numbers together. So we have 1 plus 4, 5. Plus 8, 13. Plus 2, that is 15. Remainder 1. 1 plus 2, 3. Plus 0, 3. Plus 3, 6. No remainder. Then 1 plus 4 will give us 5. The answer is 565 in base 10. And looking at the second one, which says 3A, 5B in base 12. So don't forget, like I said earlier, that anywhere we have A, it is representing 10. And anywhere we have B, you can notice somewhere that your A is 10 and your B is 11. So expanding this out will give us, don't forget to give them their powers, will give us 3 times 12 plus 11 times 12 plus 5 times 12 plus B is, okay, A is 10, sorry, and B is 11 times 12. So we now give them their powers, 0, 1, 2, and then 3. So we have 3 times 12 raised to power 3. So you need to take your time to check what you are going to have there. So we have 12 times 12 to give us 144, and then 144 times 12 again. 8, 8, and then 2, 4, 4, 1. So we have 8, 2, 6 plus 1, 7, and then 1. So we have 3 times 1728 plus 10 times 144, that is 12 times 12, plus 5 times 12 raised to power 1 is 12, plus 11 times 12 raised to power 0, 1, and that is what we have for that expansion. So now what is left for us is to multiply this out. So we have 1728 by 3. 3 times 8, 24. 3 times 2, 6 plus 2, that is 8. 3 times 7, 21. We write 1, remainder 2. 3 times 1 plus 2, 5. So we have 5184 for this. Then we have 10 times 144. I'm trying to show this so that you follow what I am doing. 0 times 4, 0, 0, 0. 1 times 4 is 4. 1 times 4 is 4. 1 times 1 is 1. So we have 0, 4, 4, 1. That is 1440 plus 5 times 12. You know your multiplication of that. That is going to give us 60 plus 11 times 1, 11. So the next thing is to add all these numbers together. We have 5184144060 and 1 1. So let's add all of them together. 4 plus 1 will give us 5. 8 plus 4, 12, plus 2, 18, plus 1, 19. Remainder 1. 1 plus 1, 2, plus 4, 6. 5 plus 1, 6. So our answer for this question is 6, 6, 9, 5, all in base 10. So I am going to leave you with these 3 questions on the board. Try to follow the steps we used in this solution and come up with your own answers. Don't forget to subscribe to this channel if you have not done so. And if you have subscribed, try to turn on your notification so that you'll be among the first to be notified when a new video is released. Until I come your way next time, remain blessed and have a wonderful day.